Games.com. Now let's look at a specific example of creating and using an abstract class. These are code snippets. I'm not showing you the whole program. I'm showing you the pieces in order to create and use an abstract class. Using the keyword abstract when creating the class makes it an abstract class. Enemy, in this case, public abstract class enemy, is going to be an abstract class. Now we know from inheritance we should place the common or share code in enemy, and then all the child classes like vampire, drone, etc. inherit from it. We also know from inheritance that we should put specific or unique code in child classes. Examples like neck biting goes in the class vampire because that's what a vampire does. Let's create an abstract class enemy to be parent class to every enemy object we plan to build. First one we'll create is vampire. Public class vampire extends enemy. That's exactly how you use an abstract class. Use the abstract class enemy to create vampire and many other classes including drone, mutant, etc. A boring game has 2 or 3 opponents. An interesting game will have 10 to 20 different opponents. Build many from enemy. Anything that tries to hurt or damage the main character should inherit the abstract class enemy. Now that enemy is an abstract class, what don't we do with it? A direct object instance from abstract class enemy can never be created. Do not do this. This is an example of what not to do. Reason number 1. The compiler will refuse to compile any code instantiating an abstract class. This line of code would light up in red and refuse to compile if you tried to create an object out of class enemy. Reason number 2, enemy is incomplete. It needs specific code from vampire, soldier, etc. in order to be a complete object. So we're not allowed to build objects out of abstract classes. So what are we allowed to do with abstract classes? We are allowed to assign child objects to abstract class reference variables. So we're going to create this enemy object and set it equal to new vampire. Remember, vampire extends enemy, so through inheritance and polymorphism, it's certainly legitimate to assign a child class object to a parent class reference variable. Polymorphism means you can assign a vampire class object to an enemy class reference variable. The object will have all the variables and methods of enemy. Get used to it. Almost always, when using abstract classes, child objects are assigned to parent class reference variables. It's what we do with abstract classes. So I've built this new vampire object and I'm showing it to you on the screen. And of course, since it is a vampire object, it will have vampire variables and vampire methods. That's a duh. But it will also have enemy variables and methods because vampire extends enemy. Since it has all the enemy's variables and it has all the enemy's methods, you can certainly assign a vampire object to an enemy class reference variable. Let's go back to our shape example and see how it would work with shape. We're going to create an abstract class shape. This is an example that uses inheritance, polymorphism, and abstract methods. Class shape will be the parent class to anything we want to draw on the screen. In a 3D game, we'd probably build the screen using things like circles, triangles, and rectangles. But in a simple 2D game, like a Mario style game, we could use elements you see on the screen, like a house or a tree. There's no reason a shape has to be a circle or a rectangle. A shape could be anything. It could be a house or a tree. What we're going to do is build an array of shape objects and see how they get on the screen using abstract methods. This is code snippets. I'm just showing you 2 lines from class shape. Public abstract void draw. You're going to want to make sure to put an abstract draw method in the shape class. That means any class that extends shape must implement a draw method. The abstract method draw will make sure everyone that extends shape has a draw method. Kind of important. because these will be the objects we want to draw on the screen. This array was declared somewhere else. This again is a little piece of code. It's not a complete program. We're going to create this shape array screen and set it equal to new shape 500. The array is key. At the start of each level of the game, you load the array with the objects you want shown on that level. That way, one program can display many different level screens. Building a new level is as easy as loading a different list of house, tree, or cloud objects into the array. This array is going to get what we want to put on the screen: houses, trees, and clouds. Once we have an array loaded with houses, trees, and clouds, which I've shown down below, we're going to write a for loop to go through and draw all these things on the screen. It's very simple. Start at the beginning of the array or the list of objects we want drawn on the screen and go through every object calling the draw method. And since draw is abstract, you're guaranteed that it will be there. I less than num shapes. The variable num shapes will track how many different objects are currently in the array. Let's say a level only has 100 objects. You don't want to loop 500 times if there's only 100 objects on it. So num shapes will contain 100 and stop the loop after the 100 objects. Since I less than num shapes was very true, it went in and executed the code inside the for loop. We got screen subscript of I dot draw, execute the draw method for the object in slot 0 of the array. This will go to the object in slot 0 of the array and execute its draw. Since it's abstract, it automatically executes the draw in the house class. That's what I'm showing with the arrow up here. If shape calls draw, it'll go down the line and execute house's version of the draw. Using a variable like x and y position, which would come from the shape variables, and the fact that we're a house object, we can draw a house on the screen, and it will go in the correct spot. Spinning back up in the loop, I++, changing the variable I to 1, will move to the object in the next slot of the array. When I is 1, it means we want to access this cloud object. 1 less than num shapes is still going to be a true statement, so the loop will execute again, and we'll go down and do the draw routine. Now, what happened when we went to slot 1 to do a draw? Again, in slot 1, we just happen to have a cloud. That's what this diagram is showing you. Go to the object in slot 1 of the array and execute draw. Since it's abstract, it automatically executes the draw in the cloud class. Using variables like x and y position, which are part of the object from enemy, and the fact that we want to display a cloud, we can draw a cloud at any position on the screen. I++ will change the variable I to 2 and we'll move to the object in the next slot of the array. As soon as we advance I, we're advancing to this third object, the one in slot 2. I less than num shapes. At this point, this is still a true statement because we have plenty more shapes left to go. So the loop will execute again. Screen subscript I, which is 2, dot draw. This will go to the object in slot 2 of the array and execute draw. Since it's abstract, it automatically executes the draw routine in the tree class, using variables like x and y position that are part of the object to place it in the right spot. In order to draw anything using this scheme, you're going to take some common variables that come from class shape, and then the local variables, the specific variables that come from class tree, and draw the tree on the screen. I++, changing the variable I to 3, will move it to the object in the next slot of the array. You can see where the arrow is saying, okay, I'm pointing to the same object as slot 3. I less than num shapes, at this point, still a true statement, so the method executes again. Screen subscript I dot draw. It will go to the object in slot 3 of the array now and execute draw because I has the value of 3. Since it is abstract when it calls draw, it automatically executes the draw method in the house class, using variables again like x and y position that are part of the object to place it in the correct spot. So there was a simple loop. On 4 objects, we can't build a very spectacular screen, but what if I had 40 objects or 400 objects? I could draw a pretty elaborate screen if I had 400 objects in my screen array. Do you get the picture? Pun intended. At this point, the loop would continue down the array, drawing more objects. When used together, inheritance, polymorphism, and abstract classes / methods means very simple code can generate amazing screens. That tiny little loop can build a spectacular video game screen.
GameSci.com